Even though it's close, of course, while they're still far. Oh, you're talking. The lady I was with, she started yelling at the car the next day. That there was a car, it was like in my lane, and she was like, what do you get? So I started laughing, and she was like, no, that's what the dude, like, just like, these people can't drive or something. They were like, we're supposed to be not only
All right, so we finally get this here. We're gonna talk about inverse. So what does this notation mean? Sine inverse. Do not say that's a sine of -1 power, because that's not a sine of -1 power. If you read it, that before I already told you, sine inverse is you should read it as a sine inverse rather than sine of -1 power, because people think of sine of -1 power, they think like this. It's equal to, let's say, 1 over sine, but this is not true. That's not true. So sine inverse means you're looking at, let's say, sine inverse of 1/2. Okay? That means, what am I looking for? I'm looking for the angle that give you y value as equal to 1/2 within restrictions. And we're going to talk about what is restriction. So this can also rewrite as arc sine of 1/2. They mean the exact same thing. So sometimes if you don't like sine inverse, you're going to call it arc sine. What is a restriction for the sine inverse? So inside a unit circle, the restriction for the unit circle is going to be at here pi over 2 and -pi over 2. So it's going to be from here to here. And think of that as like an electric fence you cannot pass through. If you pass through, you die. So you cannot get past through that rotations. So for example, if I were to ask you sine inverse of 1/2, what can you tell me? When does y value equal to 1/2 and in what angle? Because sine inverse is going to give you an angle. Okay, so let's ask Sydney, what do you think sine inverse of 1/2 is? Give me an angle in terms of radian where give you y value is 1/2.
30 degrees.
That's a good choice. And I like it. I want it in radian though. Do you know what's 30 degrees? Pi over 6 is excellent job. And that's it, pi over 6. But you're gonna say, well, how come I don't have two answers? The other answer is probably what? 5 pi over 6? But the problem is 5 pi over 6 is all the way on this side. You cannot pass this part, you die. So you cannot get to here, right? So this is the restriction of the inverse. So now I'm going to ask you a tough one. What will be sine inverse of -√3 over 2? I'm going to ask somebody here. Now put in mind that there's a restriction in place. I know Sophia and Winston already talked about this, so you guys already got it. But I need to ask somebody that who might be good. But remember, you cannot pass the restriction of pi over 2 and -pi over 2. And you only have one answer. Anybody is brave enough to tell me besides Sophia and Winston and Ksenia? Cindy?
5 pi over 3.
5 pi over 3 is great answer, but it's not the right answer. You die twice before you get the 5 pi over 3. Because the rotation is going to go here to here. And it's a great answer because it's right here. You're in the right location. But you don't have the right answer yet. So, Olivia, do you know? Negative pi over 3. You got the right answer. There's only one answer, but it has to be within a restriction. Sine inverse has to be within the restriction. You understand? Yes, Anna. That one we're gonna talk about after we talk about graphing. But right now, just know the restrictions between pi over 2 to negative pi over 2. Even you ask my AB Calc kids right now, they won't be able to tell why that restriction that way. So I'd rather spend the time when we talk about graphing, we will talk about why they have the restriction that way. It's basically the graph of a sine graph is oscillation like this, and it's gonna be between 0 to pi over 2. And only negative pi over 2 to pi over 2, you can pass horizontal line test. But right now, we don't need to worry about that because we didn't talk about graph. Okay, so it turns out there was two things that give you the same quadrant, same two quadrant. Those two, sine inverse and tan inverse, they give you the same thing. Cosine inverse, on the other hand, is the top two quadrant. So cosine inverse is the top two quadrant, or arc cosine. You don't need to know the arc secant, arc cosecant, arc cotangent. That's not that important, but you need to know that. So what do you think of a tan inverse of negative square root of 3? Can somebody tell me what's tan inverse of negative square root of 3?
Can you repeat the question?
Tan inverse of negative square root of 3. This is a negative sign. Wait, the class is already over?
10 minutes. Because I think we did last year. Remember when all those like dumb in the gym? It did like 9 and 11. Wait, students. So we for the second chart, is that today?
Yeah. Cosine inverse. That's it. There is no cosecant.
Okay.
Yeah. No, you time out.
Let's ask Isaac. What do you think?
Like that.
Yeah.
You draw 3 lines.
This one?
What do you think? Apple? Alex?
Oh, you just like that.
You need to memorize. Okay, so is that negative?
Yep, negative square root of 3. Alex, no? Cindy?
Negative 5 over 3.
Negative pi over 3 is a great answer. And that's also correct as well.
You're looking for the negative.
So those of you guys don't know, think about all the tangent. So tangent of pi over 4 is equal to 1 here. Tangent of pi over 6 is square root 3 over 3. Tangent of pi over 3 is just root 3. So this has to be the pi over 3 reference angle on the fourth quadrant. So it has to be negative pi over 3. You cannot be 5 pi over 3 because you die twice if you cross on the other side. Does that make sense? Is this okay? Okay. Let's look at some questions here. I'm gonna look at an inverse trig here. Okay, so you should be able to do the first part. You should be able to do the second part. Second part just have two things happen. Second part, I'm gonna show you. You're gonna do the second part. You're gonna do this. You're gonna say, oh, okay, let's start with the inside. When is sine inverse equal to negative square root 3 over 2? Actually, can you tell me what sine inverse of negative square root 3 over 2? Yep. So you will finish that cosine of negative pi over 3. And then evaluate what's cosine of negative pi over 3, which is equal to 1/2. So that first part is 1/2. So you can do the first two questions now. Start from the inside. Okay? Now, some people are going to say they cancel out. Well, they don't, really. It doesn't really cancel out. Sometimes it does, sometimes it doesn't. Follow the restriction, follow the inner, outer, and I will show you why that is. Yeah.
Do you like explain like that's why it's like cosine before?
Huh? Don't worry about this one yet. Which one? This one? Yeah, don't worry about this too. I will explain on the side. I will explain after class. But everything else you should be able to do. Start from the inside, evaluate it, and then go outside, evaluate it. Is that okay? So I'm not here tomorrow. You guys gonna work with each other, work through it. I don't like to take a day off, even though I'm kind of dying. But I'd rather be here, but I really need to take a day off. Okay, let's talk about question 4. Question 4 is, look at this one, it's a little bit different. Okay, start by with first question. What do you think, which quadrant do you think sine inverse is going to be? Sine inverse, which two quadrants? The right 1 and 4, thank you. So it's gonna, you gotta put 2 check mark. So learn how to do the check mark system. Very help you. They're very easy to help you on the test. If you don't do that on the test, you're not gonna get it right. Make sure you do the check mark system. It help you in life. And when sine inverse is negative, which quadrant is sine inverse negative? 4. So you have 2 check mark here. So that means I have to draw a triangle here. So remember, this is some type of angle, because every time I do inverse, I'm going to have some type of angle. This means that I have this is -3 and this is 5. Does that make sense? Because that's an opposite in hypotenuse. I can figure out by Pythagorean identity this one is 4. Because this is 3, 4, 5 triangle. So they are looking for cosine of this angle. Well, cosine of this angle is basically is adjacent over hypotenuse. So in this case, adjacent is 4 and the hypotenuse is 5. So the answer is 4 over 5. Okay, you can try to do D. See if you can do D. Tomorrow I'm not here. You're gonna finish all the way to 4E. You can cross out the question we just crossed out, which is this 2. If you're in competition, I can explain to you, but if you're not in competition, you don't have to worry about it. I want you to do D. Remember, arc sine and inverse sine are not cosecant, okay? Do not write down cosecant. Yes.
So you know how like the cosecant goes from like quadrant 1 and 2.
No, you look at a cosine is inverse is negative. Which quadrant would that be?
4.
Cosine inverse is top two quadrant.
Yeah.
Because you look at back, right? We talk about cosine inverse is top two quadrant. And when's cosine inverse negative?
Quadrant 2.
Good.
But I
So
thought
draw a
quadrant two-
triangle based on quadrant 2.
I thought it was like off limits, like the electric wire.
No, yeah, but that's only apply for sine. Sine is this way. Cosine is this way. Cosine is the top two quadrant. The fence is right here.
Does it pi for tangent?
The tangent is negative pi to pi. So this is a cosine inverse. For sine inverse, it's gonna be this sine inverse and tan inverse is gonna be like this. Tan inverse and the sine inverse. Does that help you?
This is
Very good indication.
you're always like looking at the same thing like the yeah, like the right angle when you fix it. Yep.
Apple, what'd you get? Jordan, what'd you get? Amelia, what'd you get? Hurry up, hurry up. Anna, what'd you get?
Cosine inverse.
Show. What is it? Show what? Shall call so or whatever. I don't remember. I totally just made up too.
I thought you were trying to say name.
Sophia knows what is it. What is it? What's that Chinese name with a
13.
huh? Ko Xiao Kai?
You said 13 times 13, 169, minus 24.
I will survive.
You should play that song. I will survive.
I should film on TikTok.
If you do it, I'll put the TikTok. Like,
Really? I'll become viral. Ksenia, what'd you get? 13 over 12, is that right? 13 over 12 is right because it's going to be this two quadrant, but cosine inverse is going to be this quadrant. Draw the reference triangle. This is a theta. This is a -5. This is 13. Use Pythagorean identity, figure out this is 12. So it's going to be cosecant. Cosecant is the cosecant is what? 13 over 12? And that's the answer, 13 over 12 positive. I won't be here. You can keep it. Sure.
They didn't put
Fine.
okay,
Yeah.
they didn't put in the this like score into that total.
Oh, really? So they
Yeah.
just miscounted?
Yes.
So 8 plus 10 is
And for this kind of question, whenever I grade people, if they just miss the negative sign, I just give them half a point without
no,
being worth it.
negative sign. Stop.
Okay.
So you miss 4 point here. You miss 3, so it's 7, right?
I got
7. And you missed, you got all the point here? This one? Okay, that's fine. 7.
It's gonna be 46. Oh, can I keep it?
It's related. I was like asking about this part because
Yeah, show me.
isn't that also a possible coterminal? So for this one, I put my positive and my negative coterminal, and I didn't get the point for it. What did I do?
This one's what? Negative what?
That's negative 11 pi.
Actually, that's negative 13. I believe.
13.
Let's check. So if I have here, right, that's negative 24 pi over 12, right?
Yeah.
Does that make sense? And then if I rotate this one, it's gonna be here. This one's negative 35 pi. So your drawing is already off.
Yeah, I
Because-
knew the drawing was off.
Yeah, so then it should be right here. So it should be negative 11 pi over 12 rather than negative 15 pi over 12.
That's negative 11 pi over 12. My handwriting is just.
Okay, so I'll give you this one, and I'll give you this one. Oh, this one is only worth one check. Okay, anything else?
I thought this was. Oh no, both of these?
Yeah, both is worth only one check. Coterminal can only worth one check.
Oh, okay.
What else?
No, that was it.
Here, you can have this.
Don't forget to turn off this one.
Oh, thank you. Yeah, I totally forgot already. Thank you, Anna.